So here we're going to take this review that we were working on and start going through a couple of the problems to make sure you understand some of the basics. So the first setup here is the idea that you can take the log and turn it into an exponent by going up to the other side and then back. So that this would be translated into x to the 3 equals 343. When the base is missing, it's pretty straightforward. You can just take if it's a cube on the side, you can take the cube root of both sides, 1/3 on this side and 1/3 on the other. Helps if you know the cube root of 343 is 7. So your answer, x to the 1 equals 7. I'm going to jump over to another question that has the missing value at the end, and so 2 to the what is equal to square root of 8. 2 to the x equals square root of 8. Notice that's square root. Later on we'll try a different type of root. And so this is going to be 2 to the x equals 8 can be rewritten as 8 to the half. And the 8 can be written, the base can be rewritten as 2 cubed. So that's going to become 2 cubed to the half, which is 2 to the 3 halves. Those exponents become equal. X equals 3 halves. That was the second type. This is where the x was at the end. Now the third type is a little more straightforward because the x is going to be the answer for what we're working on. 9 to the negative 2, and you're just going to do a straight calculation on that to figure out the value of x. So that's going to be 9 to the 2 would be 81, so 9 to the negative 2 is going to be 1 over 81 for x. Now those three should be pretty straightforward. I want to jump down to the ones that get a little bit trickier. Let's take a look at letter G, where I was talking about where it's not just a square root. In this case, it's a cube root. So it's 2 to the x is going to be equal to the cube root of 16. Now the cube root of 16 is 16 to the 1/3, right? You're taking the cube root. There's no square in there. There's no 2. It's just the cube root of 16. Looks like it's going to be complicated, but we can rewrite the 16 as a base of 2. 16 is going to be 2 to the 4. So it's going to be 2 to the 4 times 1/3, which is 2 to the 4/3. Working that out, we get the bases that match. So now we just have to have the exponents that match. X equals 4/3. Remember, when you're looking for the exponent, the unknown exponent, you want to make sure that you can make the bases match. That's the easiest way. Otherwise, you could do the straight calculation with logs. Next question, looking for the base when we put it together. So it's going to be x to the negative 0.5 equals 100. Now, to get rid of that exponent on the x, we're not really going to get rid of it. We want to turn it into a 1. So we can actually square both sides, and that would make it x to the 1. But if I put x to the 0.5, the negative 0.5 to the exponent negative 2, then it's going to be 100 to the exponent negative 2. On the left side, it's going to wind up being x to the 10, wrong, x to the 1, and then the 100 to the negative 2, well, it would be 1,000 if it was just a positive 2, but it's going to be 1 over 1,000 because it's a negative exponent. 10,000, not 1,000. And then the last one that I want to just try out here, it's a straight calculation again because, no it isn't, because we're actually looking for the exponent. 9 to the x equals. Now 27 here is going to be fourth rooted. So that's 27 to the 1/4. Got to make the bases match. So it's going to be 3 to the 2x. I'm going to make that exponent 3 squared. The power, I should say, 3 squared. And then the 27 is going to become 3 to the 3, and times a quarter is going to be 3 to the 3/4. And now we make these exponents equal to each other. 2x equals 3/4. And we solve that by dividing both sides by 2. X equals 3/8. Just remember that when you divide 3/4 by 2, it's the same thing as multiplying by a half. And so now we want to move to the next section. I've got a couple of messes here, so let me just clean that up first. But we're going to work out question B and C And I want to explain how these log laws are going to work. The main thing is to understand that the multiplication within a log will turn into addition of two separate logs. The division within a log will turn into the subtraction of two separate logs. And an exponent on the argument in a log will be multiplied out in front. So let's take a look, starting with question B. This is going to become, there's a multiplication on top and a division on the bottom, so that's going to become log base b of n plus log base b of p, and then you're going to subtract for the q log base b of q. When we talk about the next one, there's two things going on here. We've got a multiplication of 7 times the bracket and that exponent on the bracket, which we're going to be using the property up above here. So first, split the multiplication into the separate logs, the addition of two separate logs. So log base 5 of 7 plus log base 5 of x plus 2 squared. And now that squared is going to be multiplied out in front of that second log. So you're going to get the 2 going to go out in front here as 2 log 5 base 5 of x plus 2. Now don't think you can start splitting up this addition of the x plus 2. They just remain exactly like that. The question is done. Let's move on to one that's got a few of the more complicated setups. So we'll move right down to letter G, where we have a multiplication and an exponent. Now the thing to recognize in contrast to question C is that the exponent is on the entire bracket, so that's going to wind out in the front of the entire log. So that's the first thing, order of operations, that we would take care of. So log base 6, you're going to have that 3 out in front of it of 2x plus 1. Now when I go to split this multiplication between the 2 and the x plus 1, I've got to remember this 3 affects everything. So I'm going to put a big square bracket there. So it's going to be log base 6 of 2 plus log base 6 of x plus 1. These guys all follow the same kind of rules. When you get to letter H, remember that the exponent on that square root could be rewritten x to the 1/2, and you can follow the same kind of routine. On the back, we have the questions where we're going to use the log laws again, but this time we're going to use them in reverse to the way we did it previously. We've got an addition of two separate logs, the bases have to match, and we're going to turn it into a single log, knowing that additions will turn into multiplications, subtractions will turn into divisions, and exponents or multiplications in the front will turn into exponents. So log base 2 of 5, log base 2 of 8 will be log base 2 of 5 times 8. Now you don't have to do this every time, but I'll just show you the gruesome step here, and that's going to be 40. Next one, log base 4 of 45 and 3, same kind of routine. I'm going to jump over to letter C, which is for natural logs, so that's log base E, so we write it as ln or ln. So this is going to be ln of 7 times 8 divided by 4. 7 times 8 divided by 4. Yeah, this is going to simplify, and it's going to become simply ln of 14. Couple of steps in letter D, because we have this 2 out in front, that's going to become the exponent. So it's going to be log, this is a base 10, so we don't have to write the base at all, log 25 squared divided by log of 5 cubed. Don't have to put the log again because we're combining them, so it'd be just divided by 5 cubed. Cleaning that up a little bit would be log of 25 squared, which is 625, over 5 cubed, which is 125. This reduces to log of 5. Log base 10 of 5. If we knew how to work that out, we could have simplified it further. Now looking at question F, we have the division in that bracket or the beginning, and is log base 9 of 2, but log base 2 of 9, log base 2 of 10. You think you want to divide this, you think you can turn it into a subtraction. That would be using the log laws illegally. So we're actually going to take a look at the separate parts of this. Log base 2 of 9, and you say, oh, maybe I can work that out. equals x. Well, you would wind up with 2 to the x equals 9, and that won't simplify. In fact, not much we can do with that. Instead, it's a matter of taking a look at this entire fraction. And this is the change of base formula. That's the one that says that you can take a log and rewrite it as a division of two logs with a new base. I believe it's log base a of b equals log of b over log of a, and then you can put any base in there, log base 10 of b, log base 10 of a, any base at all. In this case, let's say it was log base 2, because that's the way we're going to do it in this particular question, but backwards. So log base 2 of 9, log base 2 of 10 is going to translate into log base 10 of 9, right? That's the property backwards, and minus log base 3. And notice log base 3 has an understood base of 10. It's a common logarithm. Breaking that apart, it's a subtraction is going to turn into a single log, which is going to be divided. So log, big bracket, division, 9 over 3. That comes together. And that's going to be simply, oh, I'll put the 10 for the common logarithm. It's not necessary. And that's going to be log base 10 of 3. Complicated question, and that only comes with having a little more experience on what you're doing. Time for a couple more. We're going to section 4, and we'll start off with question B. It's got the elements of A, but we're going to do D also to see what goes on there. So I've got a subtraction of the logs. They're all base A, and then an addition. So the log A of t minus 3 log A of 2t, 2 log A of 3t. Well, big log in the front, and then we're just going to put the bracket here. The first part of it is going to be the t up on top. The 3 log a of 2t, it's going to have the exponent move up on top of there, so it's going to be 2t cubed on the bottom. And then the last one, it's plus, so it's going to be times 3t squared now. Whoops, that's squared on that bracket. 3t squared on the top. And that bracket is squared. And then it's a matter of simplifying that bracket, cleaning it up. So on the top, that's equal to 9t to the 3. And on the bottom, it's going to be 8t to the 3. So 9t to the 3. Did I say 3? Yeah, okay. And then 8t to the 3. And those t to the 3's cancel, so it's basically log 9 over 8. We're going to put this down here, start off question D. This one is a little bit more tricky because we have a division and two divisions actually. So we're going to rewrite this first one, the subtraction, as a division, and the second one as a division. Big ugly exponent, but that's going to go up in front there. Same with the other one. And so we're going to have big log, big fraction. Now I probably don't need this bracket, but I'll put it there for now. The first term is going to be x squared minus 1, and that's all squared. On the bottom, it's going to be divided by x plus 1. And for the second part, it's going to be divided by x minus 1 squared. Now, you might recognize the difference of two squares here on the top, and there's still the exponent of 2. So I'm going to rewrite this so I can do some division of top and bottom. I'm not going to write the bracket this time. On the top, x squared minus 1 becomes x plus 1, x minus 1. But because it's squared, we're going to have 2 of each. And on the bottom, we've got the x plus 1, and we've got the x minus 1 squared, so that would be 2x minus 1's there. And now the cancellation fest begins. Cancel all of these, 1 of each, and at the end of it all that's left is log of x plus 1. Nice little question, okay, cleans up nicely. And question F is going to give you a little bit of a challenge. We'll get back to that later because I'm out of time for the video.